Hi and hello guys, welcome to PrepBytes. This is Mahati, and in this video we're gonna solve top 25 questions of Google. So before actually going into the video, I wanna tell you that I'm gonna put up a link in the description which will be so useful for you to crack upcoming interviews of companies such as Google, Adobe, Microsoft, Amazon, Flipkart, etc. etc. So this coding platform of PrepBytes contains all the coding interview questions which were asked in companies such as Samsung, Google, Amazon, etc. So make sure you visit the link, and before actually going into the video, make sure you're subscribing to the PrepBytes channel, like this video, share this video, and please do let us know what you feel about the video in the comment section. Right, so let's just quickly jump into the video. So before actually going, so this is how the platform looks like. You'll have different companies questions. So let's just go and go for the Google questions. Yeah, there we are. So we're just gonna go and do some questions, not all questions though, but some questions. But I'm gonna tell you that these will help you a lot, right? So before actually going, let's just start with the problem statement, right? You can see here that you are provided with an array of strings and you have to find the longest string, which is lexicographically smallest, and also all of its prefix strings are already present in the array. Now let's just understand one term here, which is lexicographic. So what does this lexicographic means? So lexicographic means the order of the alphabets according to the dictionary. Right, order of the alphabets according to the dictionary. So whenever we are, so he like simply said that whatever the string we need to find should be lexicographically small, which means in the dictionary it should be coming first, and it should be the longest string among the given array. So let's just understand this with an example, right? So I think we have an input format where the length of the array string and the second line contains element of array. Okay, so let's just go and understand the sample test case, right? The sample input. So the input given is 4, which means there will be 4 strings, and we have AB, ABC, and ABD, right? So this is what the problem statement actually says, is that I want to find a string which is lexicographically small and it has to be the longest string as well. So when I'm talking about lexicographically small, what will happen, right? So first we'll just forget about this lexicographic thing. We'll just go and simply, find the longest string we have. So what is the longest string here? The longest string length, we know that it is 3, right? These 3 are 3. These 2 are actually of length 3. Now there is another point here which is asked, is that also all of its prefixes strings are already present in the array. Now what does this prefix means? Now let's just take A, B, C here. I'm just taking this string, right? So when I'm talking about A, B, C, which means here A should be present, AB should be present in the array. So which means all of the prefix elements. For example, if I'll take ABD, then also A should be present and AB should be present, right? So we can see that we have AB and A as well, right? Without going into the logical approach, if I let you know how this is gonna happen, then you can see that I'll check for the longest string. I can see that these 2 are longest strings, right? So if these 2 are longest strings, I'm gonna check for one string that whether I have prefixes or not. So first I'll check for A, yes, A is present. Then I'll check for AB, then yes, AB is present, which means these 2 strings are longest strings as well as their prefixes is already present here, right? So which means I need to compare these 2. Now how I'm going to compare? We already know that these prefixes are same, right? So all we have is C and D left, and we know that C comes before D. So which means ABC is our answer. right? ABC is the string which is lexicographically small as well as longest string of the array, right? So let's just see how we're gonna approach, how we're gonna actually do this in the code, right? Okay. So if we want to go into the logical approach, we know that whatever the strings we have, for example, we have AB, ABC, ABD. So let's just say we have all like large strings, for example. I'm just gonna go and simply explain you with this example only. So imagine if I really want to traverse and go to every string and actually check, right? So it will be big O of n. The linear time complexity will be more, right? And it is difficult to actually go into every string and traverse and check whether the prefixes are present or not. So that's why generally we'll do that approach. That's a brute force approach. Whenever you see the question, that's what you will get. That I'm gonna go and check every string, traverse through every string. Then I'm gonna check it. After checking it, anyways, I will get to know and all, right? But that will be a brute force approach, and it will be waste of time and waste of space as well. So we're gonna do some logical approach here. So every time when I'm gonna check for the longest string prefixes, I should remember whether that prefix is already present or not, right? So whenever there is a topic of actually remembering, right, then only one word should one thing should strike in your mind, which is hash map, right? So hash map generally used to remember, right? So what we're gonna do, we're gonna go and whenever we're going to check the array, so what we're gonna do, we're gonna store these prefixes into hash map. First we'll sort out the array, right? For example, A, AB, ABC and ABD. That's what we're gonna do. Then we're gonna insert all these into hash map, right? Then we're gonna check, then we're gonna traverse through all the array once just to check what are present and what not present. We'll get the answer easily. So that's how you're gonna solve it. This is the simple and optimal approach, I would say. So let's just try doing another question. This was all about this question, right? Let's just go and do the building palindrome, right? So whenever I am actually talking about palindrome, let's just understand how this palindrome actually comes. Right, before actually getting into the question, I'm gonna tell you what's a palindrome is. Let's just take a popular palindrome, which is madam. Now you can see that the first and last letter are same, second and second last are same, and the middle one being common. It depends upon the string length, whether it's even or not. So this thing is known as palindrome. Right, kind of mirror image of half. So, so the question here says, now you understand what's a palindrome is. So you're provided with a string S and you have to find the minimum number of characters to be inserted. So we need to find minimum number of appends. Minimum number of appends. Right. So let's just go. Before actually going into the sample test, let me explain you with a simple example. Right, let's just go and do with prep. Right, now we have to make it a palindrome. Right, we have to make it a palindrome. So when I have to make it a palindrome, what we're gonna do, we're gonna take this first letter, write in the last, take this second letter, write in the second last, take the third letter, do this. Now this is our palindrome. Right, so which will include you to actually go on and putting it. So let's just say sometimes we have so in this approach what we did, we just took the last element and we reversed all the characters, right? But there are some kind of words such as grass. We'll do the same approach with this. We'll keep the last letter, right? Then we'll reverse all the letters, A, R, G. Now you can see there is an extra element here, right? There is an extra element which is totally unnecessary. right? So in the question, what he's saying that how many minimum characters should be actually inserted to make a string palindrome. So for that approach, what we're going to do is, right, so we're going to take our word prep. We'll take a loop, we'll, build a loop, and we'll start eliminating one element. For example, if I'm taking prep here, I'll eliminate this element. I'm eliminating, I can see that I'm left with REP, which is rep, right? Which is rep. So I can see it's not a palindrome. If it's not a palindrome, I'm going to remove again the next element. I can see I'm left with EP, which is not a palindrome as well. Then I'm going to remove another element, which means I'm left with P. And single digit is always a palindrome. Single letter is always a palindrome. So which means I had to actually remove 3 elements to make a string palindrome. Right? I had to remove, listen to it carefully. I had to remove 3 elements to actually go in and make a string palindrome, which means I will have to add 3 more elements, which means RE, RP. I need to add these 3 elements to because in the question itself, it is mentioned that we need to actually do the insertion, not removal. So, but what we'll do, we'll eliminate them. We'll eliminate and we'll check for the common subsequence, right? Common subsequence, and then we'll insert. So that's how you're going to do the minimum number of applets, right? So let's just understand the sample test case here. Yeah, sample test case we have. Give me a second, guys. Yeah. Okay. So we have A, B, C, D here. Right. What I'm going to do, I'm going to first remove A, check whether B, C, D is a palindrome or not, which is not. Then I'm going to go for B, check for C, D, whether it's a palindrome or not, which is not. Then I'm going to remove C and check for D, which should be a palindrome as well, but which is a palindrome because it's a single alphabet. So I've removed 3 elements, which means I have to insert 3 elements, right? So that's how we're gonna do this question, right? So this was the logic of this question. Let's just jump into the next question quickly and do the next question as well. Okay guys, so in the next question, we're gonna see a detect game, which is actually also popularly known as threesome closest, right? So what the actual problem is saying, let me tell you, right? Yeah. So in this, the problem is saying that you will be given an array, right? You will be given a normal array where you will have integers. I'm just taking an example of, let's just take an example of what we have in here, right? Sample input, right? Okay, input format, the first input contains NNK where N denotes the size of the array. And K denotes the target value. Okay, and K denotes the target value. So let's just say, I'm just giving you the example. Let's just say I have -4, -1, 1, 2, 5. This is the array. And I have a target value saying 2. Right. So I'm given with an array and I'm given with a target as well. Now, what does this mean actually? Right? What do we need to do actually? So this is the target sum. So the question says that there might be a pair of 3, right? There is a pair of 3 which will actually give a target, or we need to find closest to the target, right? Closest to the target. So now how are we going to do this? Generally what we're going to do, a brute force approach. First we'll fix this element, then we'll fix this element. So for this there will be a for loop. For this, there will be a for loop, right? Then for traversing through these 3, we'll have another for loop. So which means we'll be having 3 for loops. So it will be of big of n cube. 3 for loops, right? So which will be lengthy, complex as well. So what we need to actually do to reduce this time complexity? So right, so time complexity, we know that it is already big of n cube. Now we need to actually try to reduce it. Now how we gonna reduce it? So let's just start sorting it. Now here I've written all in the sorted way itself, but if it's not sorted, the given array is not sorted, so first thing we need to do is we should sort the array, right? Once we sort this array, once we've sorted this array, what we gonna do? We gonna fix one element. Now how that is gonna happen? So already we know that we have our array already sorted, right? So let's just understand it with example. That will be a lot more better than actually not understanding without an example. So let's just say this is my given array. So -4, -2, -1, 1 and 5 is my array, right? So now what I'm saying, what we're gonna do is we're gonna go for the 2-pointer approach. Now how this 2-pointer approach works, right? Using a brute force method, I already told you, it's gonna be like take long while to actually do this. So that's why we're gonna go and approach this problem using 2-pointer method, right? So before actually going into 2-pointer method, what we're gonna do is we're gonna fix an element. So we're gonna fix first element. We have sorted the array. Now we're gonna fix the first element. As soon as we fix the first element, I'm gonna go and use 2 pointers. One at the start, one at the end, right? So now when I'm using this one at the start and one at the end, what's gonna happen is, let's just see. Let's just build the first case, right? Yeah, no, I'm gonna take a look. So we'll just build the first case. So in the first case, what I will have is -4, -2 plus 5, right? Which means I'll be having -6 plus 5, which is my -1, right? Which is my -1. Now let's just say the target given to us is 2, right? So is it greater than 2 or less than 2? It is less than 2, right? So it is actually, yeah, it is actually less than 2. Now if it's less than 2, we know that we need some closest number to 2, right? So what are we gonna do? When we need some close or some more nearest number, we're gonna go and take this pointer and go to next stop, next place or next position in the array, right? Why we are doing this? As soon as I move my pointer, starting pointer, what will happen? The value will increase because the array is sorted. So the gap between the target and the achieved output will become less. So we can have the closest, right? So again, the next case will be -4, -1 plus 5, which is 0, which is again less than 2, right? So my pointer will go again here. Now it is -4 plus 1 plus 5, right? So which is 6 minus 4, 2, which is 2. So if we are achieving the sum, the target, it's fine. It is like best. But we'll try for the closest. But now we have got the sum. But what if you didn't get the sum here as well? Then what are you gonna do? You're gonna go and fix another element. Let's just say I'm gonna fix -2 here. As soon as you'll fix -2 here, what are you gonna do? You're gonna go, pointer will start from here. So your first case will be -2, -1 plus 5, which is 5 minus 3, 2. You got the again, right? So this is how we're gonna do. We're gonna take a pointer, 2-pointer approach. We're gonna have a start and ending. Then we're gonna move accordingly. Then we're gonna shift pointers accordingly. That's how we're gonna reach the answer. So that's all for today's video. I hope you understood the logics and approaches of these questions. Logics and approaches seem, before actually knowing going into the logic or going into the approach, generally it feels like it is tough. For example, let's just see this question. right? Sample input, we are given that the array length is 6 and we have a target as 7, right? So we'll do this question. Now I have array length, let's just say 5, 6, minus 9, 9, minus 2, 8. This is the question, right? Now we have a target of 7. This is our target. So first thing what we need to do, sorting. So let's just sort. I'll go for first negative numbers, minus 9, minus 2. Then I'll go for positive numbers, which is 5, 6, 8, 9. Right, first what we're gonna do, we're gonna fix this number. Then we're gonna take this as a pointer, this as a pointer, right? These two are my pointers, so I'm gonna go for the cases again. As soon as I'll go for the cases, minus 9, minus 2, plus 9, which means I'll be left with minus 2, which is not, minus 2, which is less than 7, which means I have to remove this and go for here. I'll have to shift right because it is less than. So and as soon as I'll be shifting it, I'll be left with minus 9, plus 5, plus 9. So I have 5 here, right? Now again 5 is less than, right? So what we'll have, let's just move the pointer, minus 9, plus 6 and plus 9, which is 6, which is far more closer, right? But you can see the next thing as well. When I'll take minus 9, plus 8 and plus 9. 8 as well, because even though it's one digit before, one number before 7 or one number after 7, they both are closest, right? So this approach is the most optimal approach because it will save your time and it is easy using a two-pointer approach. So that was all about today's video. Thank you so much. Please do like the video, share the video, and if you have any queries, if you have any doubts, if you want to have more such content, let us know in the comment section. We'll try our best to deliver it. Thank you so much.